Let's start the today's session. Right. Let's start the today's session. So today's session is starting. So from tomorrow I solved till till I think I solved till the print k element, right? Sorry, start to take maximum. Yeah. Tomorrow I solved till the print all the element at a k distance, right? I solved from this yesterday. Now I have to move next question. Right. Minimum time to take to burn all the tree from node. Right. This question. What is the question says? Question said like you are given the root of binary tree and the target node, and you have to return the minimum time required to burn the entire tree if the target node is set to fire. Okay. So in 1 second, the fire spread from its node to left, right, and check. So you have to first make a parent. The question suggests that it's parents. So you have to first, it's a clear that you have to make the map of a parents, or you can use the um, first you have to make a parent. That means the a structure like a child child parent combination, and use the BFS. Like from the target, we have one. In one step, we have one, the two, three, four, five, one, and next step we have one three, and there is nothing, and in next step. So what we have to do here? We have to just make a like a unordered map. Sorry, unordered unordered map, right? We have to take a unordered map like what? Node, 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 parent. Okay. So let's write a helper parent node root. Right. Now we have to do what? Now what we have to do? We have to just, if the root is not present, just return, right? And if if the root left is present, then what we have to do? We have to take a parent root left should be the root, and call the helper function of a root left. Now else, sorry, not else, if the root right is present, first mark that root right, right, root right, parent should be root, and call the helper function of a root right. So this all gives the like all give to the relation of a child or the parent. Or now what you have to do? Just you have to do like a binary search. Okay, not a binary search. Sorry, do like a BFS node star. Take a pairwise, right? Take a pairwise, or not take a pairwise. Not necessary to take a pairwise. Just take a node and q, and you have to push q dot push. What you have to push? push the target, right? And take a time timer. Timer should be what? Timer should be 0. Now, what you have to do here, timer should be 0. Now, you have to take a set for visited, right? For visited. Now, while queue is not empty, queue is not empty, what you have to do? You have to do like an queue dot size. While not a and q dot size, you have to while just use right like the auto node and node q dot front, q dot q dot front, right? Q dot front and uh, q dot front and q dot pop back. Now you have to do what? Just take like what you have to do, like for each label you have to take a inquiry like that now. So you have to use the q dot size. You have to do this because we are doing like a label wise traversal. Mm, like the first time timer should be plus plus. It's become 1. Now again it's 0. So if it is left, if the node left is present and left is present and it is not visited visited dot visited dot count node left, that means it is not present. It is not present. What you have to do? If it is not present, you have to do like just q dot push back, push the node left and mark visited visited node is equal to true, right? Oh, sorry, not a mark, but insert left left. Now again, if the node right is present, and it is not visited, right? Not visited. What you have to do? Q dot push node right and visited dot insert node right. Now again, you have to do just one thing. What? If the parent dot count of node, if it the node is present and add the visited dot count not present the parent root for parent node, you have to just what to do? You have to just push parent of node and insert into visited dot insert parent dot node. Now just return the timer. You have to call like call helper parent and the root. So just like what is the error? Helper dot Helper, where is my helper? Okay, sorry. It's a copy, it's a paste from here, and it's a paste from here. Right. Now let's see. Push target. Oh, it's like a, you have given a target of not a root but a index, but a value, right? So you have to also do here what? You have to make a node star, mm, take a in target. Why I am taking here target and target, right? Calling from left right, and if the if the root data equal to target, so star should be root, and just visited here from the root, push back parent, call root, and call here target. It's like that. Void insert was not declared. What? Insert visited, set data structure I use. Insert. Okay. It's like a giving 4. Why 4? Like from 0 we are opening 1. 1 we are pushing back like from 2 we are taking 2, and timer is 0. Now from 2 we are burning the 5, 4, 5 and 1, right? So it's become timer 1 second. 1 second. So it's a timer should be, I think timer should be this. So it's given that timer, correct output is 1. Why? It's like what is the 2 1 2 1 2 1 null and null. This is the right. The let's see the tree. Like 3 is 2 1, right? And the target is 1, right? Target is like 1. So target is 1 like the 1. So we are 1, just the 1 now. 1. It's a moving like a 1. What we have to do here? Ah, now I get it. What you have to just take right timer, auto in timer, or all are connected like 1 2 3. So timer should be 1. We have 1. Now it's a timer 2. Now 2. Now we are initializing, so it's a timer 2. 2 minus 1 1. So it's a right answer. Why are this giving wrong? It's if we found the parent and parent is not visited, we are pushing the parent, right? Okay. So it's like 1. There is nothing. There is nothing. So it's a parent. Yes, there is a 1. So it's like a 0. We are initializing 1, and we have 1. So 1 we are pushing. Now we have 2. We have again 2. So we become 2. Now from the 2 we are nothing. We have nothing. So just we are empty outside, outside from out from the. So if else, and outer condition. Now use the set data structure. Now return the timer minus 1. So it's like a more like a good question. Why this it's not giving the right one? Like why? Custom input. With this, it's giving the your output is 1. Why 1? Left, right not visited, insert right and right, insert parent visited dot parent. Okay, so it's like left and right. The right should be parent to all the target, all the value. So it's 1. Now target is 1. So we are just targeting the and okay. Visited dot insert target. You have to do this now. You have to do this. We are not pushing the target value, right? That's why it's giving the wrong answer. Now all got it. We have to just make a first parent or child of a left and right child parent. Now just use the BFS like finding the timers just like this. So now let's move the next question, right? Count the question is like count the complete tree node. Okay. Like 1, 2, 3, 4, 5, 6. Okay. Given the root of the complete tree, return the uh, tree number of nodes in a tree according to Wikipedia. Okay. Each level except possibly the last one is completely filled. Okay. So one level, it's two level, it's four level. So what should be the design algorithm less than? Okay, design algorithm less than. Okay, so you can't use the like a BFS type. You can't use like traversal like that, right? So it's the first order, second level, and the third level. Mm, level wise level. You can use the BFS, a level wise traversal. It's a easy one, right? What I'm trying to do, like how can we approach like one? You have one, so just index one, two, two. Now it's a five, so it's five. Possibly the last one. All the complete data. So what is the level? First level first, second level complete. That means the two into one, two. Now it's a third level should be. It's like a third level should be this 1, 2, 3, 4, 3, 2, 1, 2, 3, 4. So 2 into 1 plus 1. You have to level wise. So 0 plus 1, 0 into 1 level 2 into 0 plus 1, it's a 1. 2 into 1 plus 1, it's a 3. No, it's a 2. And the 2 into 2 plus 1, it's a 5. So it's a 4. Level wise traversal. Level. How much should we take? So you have to just use first the level wise traversal, right? And otherwise, let's take tree, three nodes in each level, each level. Like in data structure, represent the distance between the root 12. So it's a 0, it's a 2, it's a 4, it's a 3. So last level should be you have to count manually, right? If we use the binary search, sorry, not a binary search, sorry, not a binary search. If we use the like a traversal, like what traversal? Like we are here, we are making how much? Do you have one? One plus one. One left, right, one, return one. It's a three, return four. It's a total node you have to count. So you can use the total node formula. Like how can we get it like so? What I'm doing, like if the root is not present, you have to just return the 0. Else you have to count the left helper. Sorry, count the node call the count node, root, root, left, and int right should be the root, root right, and just return the 1 plus left plus right. This should be this should be one solution, and other solution might be the BFS like a structure, like a level wise traversal. You're traveling all the levels, and you level all the traversal. You visit all the level and finding how much node are present in each level and adding to the sum. Right. I have solved this previously. Let's see how I solved it. So yeah, I used the level wise traversal. Right. This was level to find counting the node in each level. Right. We have to just count the root each level. Now let's move the next question. Right. Required needed to construct a unique requirement need to these two these one with good question, right? Like what this question, geeks want to know the traversal required to construct a unique binary tree. Given the pair of traversal return true if it is possible to construct unique tree, unique binary tree from the given traversal, otherwise return false. So each level is represented like, so this one is not a very hard question because we have to these all are good question, right? Like construct, so same this approach use same, like how can we construct from the pre-order, like construct a binary tree from pre-order and in order, like construct a binary tree from the post order and in order, this one. So this till like here that one represent the post order, two represent the in order. So post order or in order we can construct, right? But the post order or pre order we can't construct, right? So this was just like that. You have to just return if the a is equal to 1 and b is equal to 2, just return the true, true. Else if a is equal to 1, in order or post order, and b is equal to 3, return true. You can make a unique tree, else otherwise return the false. You can't make the unique tree from the 1 3, return 0 correct output 1 3. Okay, one, what is one? If pre-order, okay, pre-order, sorry, it's like a, we have to make a here like b, it's like a b, it's like a one thing is two. You have to just take a uh, you have to just make a, like a, if a, if a is equal to 2 or b is equal to 2, if anyone this, you have to just return the true statement, else return the false statement. This one is good because in order is present, then you have to, the answer is always true. Oh, so yeah, just you, you just maintain. You have to also check like if both are in order, you can't make, right? You can't make like a is equal to 2 and the b is equal to 2. You can't make, you have to return false because the in order can't give you answer. uh, if so this one is good. Let's say Now this one is good question, right? So what is this question said? This takes some time for me to solve because you are given the pre-order in order where the pre-order is the date. If pre-order is the pre-order traversal of a binary tree, okay, and the in order is the in order traversal of a by same tree. You have to return the construct and return the binary tree. Okay. So what we have to do? We have a pre-order 3, 9, 20, 15, 7, and the in order like 3, 9, 3, 15, 20, and 17. So we can check like we can go like a pre-order to in order, right? So if we take like a root should be the pre third one, the root should be 3, and its value should be mm, find the position of 3, position of 3. So it's here left and here right, right and left. So it's left, right, left. Okay. So it's like a second is 9. So it's 9. Nothing much. And third find position. So it's like a position is from here, here. What we have to do here, we have to just take an index. If you want to construct from that, so we have to take an in order, or pre-order, or the index index range, like the left or the right. Hmm, good one. So you have to construct the binary tree. Like you have like what we have to call here. Take a if we have what we have to do here. Like taking the in order traversal, right? 9 index. This is good. Index plus 1. This is good. From the left side, like the root left, calling the helper function or a build tree function. Index should be plus 1. Pre-order, pre-order, and its position. Position should be from 0 to from a start to position minus 1 and position plus 1 to end. This much. Call root left call, right call, else return the root. This one is good. Now question arise like if we going like a 3 we made, now we move to the 5, so it's like a 5. So I don't think this can be approachable. Like we have to find the position, right? Like how to approach? Can I like a 3, 3, 9, 20, 15, 7? It's a 3, 9, 20, 15, 70, 7. So why this given the in order? So it's like a we have to just what? We have to just like order in minus return. So it's like a order index should be one, and the priority not a, it's like a, what we have to do? Just take a map. First, take a map which is indicate the position, like a map, unordered map, unordered map, ordered, ordered map, int, and the int position, uh, right? Position. Now, if you find the element, so what you have to do? Just to do what we have to do here. Mm, just find the position of the tree node helper, build helper. So we have to just count that how much index would be there. So it's like mm, you have to take like a what we have to take. Like an index should be find, and you have to take like a what we have to do here. So yeah, right. What we have to do here, like if we find the position, right? Position we find, and now let's suppose we have to do like what? Like first we have in order, in order dot size, and put all the n to n position dot in order, in order dot I is equal to I, right? This gives the position of the all the in order traversal. Now we have to just make a helper function, like return the build. What we can do here, like we can give the pre-order, 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 not give the a start, end, a start, end, and the index, start, end, start should be, end should be and minus one, and the start should be zero, and and the and the index should be zero. Now what we have to do here, like the question is like how. Like 1 plus 1. So it's mapping index. I got it. It's all like a putting index, we are not just, you have to like a starting index or inversing index and take a in order, right? In order, in order, in order. Now just build a free node, like help, build, build vector in pre-order int a starting a start int 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 index and the vector in order. Now let's suppose what we have to do here. Now we have to what, like we just have to find the, we have to find just what we have to find, like the element or the current element. What current element is pre-order, pre-order index, pre-order index. Now pre-order index, now it should be increases, right? It should be increase plus plus. So just what we have to do, what you have to do, uh, like if the st is equal to end, you have to just return the what, just make a new free node, right? Free node, new node is equal to new free node is equal to pre-order, sorry, current. Just give me 1 second, right? I will just give me 1 second. Just 1 second. Just give me 1 second. Just give me 1 second. Uh, what I'm trying to do, okay. Now what we have to do here, we find the, so we if the node, so just return the node, and now we have find the index, how much index, right? Okay, position of the this, so map dot, sorry, position map dot position one, it's a mid m, take m, current, and just like a new node, new node left, call the build function, it's a pre-order, pre-order, and the start should be a start, and mid should be m minus one, and the end should be end, and index should be index, and the in order should be in order. Now same as new node, right? Build pre-order Start should be m plus 1, and should be int, index should be index should be index. Are you sure? Index should be index. Yeah, index should be like index and in order and in order. And last return the new node. Like so let's try this give the compiler error. Why? A start sorry a start, not a st but fully a start. Start why a start. Let's take it. Or if the start right a start and return the null str null ptr. Build pre-order in order pre-order empty index in order. I think this is right. Why this giving the wrong and build too many options for 000 build pre-order start mid okay start not a start index in order build three load node. This giving the wrong answer on 2030. Why? Hmm. Why this giving the wrong one? Like I think the size should be equal, na? Why? Pre-order, pre-order. Hmm. Size should be equal. Why it is giving the wrong one? Like a three. Where is wrong? Double line. Plus mid plus one, mid plus two. We are making the index should be zero. Calling from the window and calling index. Starting mid. Building from this. Why it is giving the wrong one? Start end should be left right. The three nodes should be. Why? This 20, 30, 30, 20. Okay. So it's giving the double, right? Just, can I make here like 2 plus 1 and 1 plus 1? 1 plus 1, 1 plus 2. I'm giving the index to be right. It's negative, negative. It's giving what? Okay. Let's just ask from the GPT why this giving the wrong one. Why this giving the wrong? Let's ask from the so why this giving like a right Index should be index. We are checking the index. We are taking like how much should be left side and going to right side like so we make yeah, I think this is good. Why this giving the wrong answer? Chat bhai chat. Hmm. Where is wrong? What is the wrong or where is wrong? What is the wrong? In order plus one. Index should be plus one. It's plus one plus one plus one plus one mid in plus one index minus one, right? St index and the index should be all. So yeah. It's all things are good. What is wrong? What is the wrong here? What you are trying to apply with left right सही है left right से इनपुट इतना for example इतना so global shared pre-order attached इतना pre-order to zero ये तो अपना कोड दे दिया what is wrong okay the another is इतना so you can remove इतना that's a very person remove you can remove this right it's the overflow condition might okay so if we take like this and this if we take like this is the overflow condition yeah index will be overflow position index plus plus start index one why my code uh, index is passed by value so update while make constructing testing not reflected when constructing suffering okay passed by value so it's like the index plus and just remove from the here ah sorry let's take it from here now it should be passed oh sorry it's remove here on here now it's should be the pass okay. It's like an index and index should be zero yes so part by value reference that's why this is not showing that here right so if you can't take you have to just remove this approach and take like a pre index is equal to zero and just pre index plus plus just remove from here the Just cancel it out. Just remove completely this, and also from here. Just now you have to call three node plus one. Yes, one input. This should be. So this is the now next question should be like to construct a BT from the pre-order in order. We just construct, oh sorry, we just construct, right, a pre-order. Now post-order in order. Now post-order and in order. Given the binary of in order and post-order. So post-order should be, it's a 20 again. So it's like a from the main question is here. This is a good question, good one. Like we have 3, 7, 5, 20, 70. Now we have 3, 9, 15, 7, 23. Try this code. I will be back in 2 minutes. I will be back. Let's see this question. Right. So this question said like a pre-order or not. So it's a root is here. We have to find position. Now the index should be we have the, from the left it from for the right left for the left side of it should call the left just minus 0, 1, 2, 3, 4. So just 4 minus 3 all the index starting. So it's the left position should be like where it should like start and end all good, and the index should be negative minus 1. Starting it all good. Now just we have to move the how much first left should be called from this one to this one. This one is to the left side. Start from and that should be what like we have to find the how much position like a position should be like a 3. We have find the 3 how much element is to the left side of 3. So it's an index is 1. So 1, 2, 3. 3 element is so minus 3. So it's giving the 1. Now we have a stick that means 0 to 1. Okay. And for this, for again for this, so you have to take the end, end, and the position plus 1. and the index should be, and index should be, what should be the index? Index should be position, because it's very, this one is good question, like construct the binary tree with the pre-order, post-order, and pre-order. So we have to find the we have to just find the index. Just make a map again. Make a map, unordered map, 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 or and position. Now we have to just what to do. What you have to do? Just just try to do like a position. So tree node build. Now we have to just take the in order dot size, and just make the position and I plus plus. So position plus in order I is equal to I. Now you have to take. Now what we have to take, like call the helper function, and what should be the, it should be the in order, post order, starting should be 0, ending should be n minus 1, and index should be n minus 1. This should be right. Index should be 1 minus 1. Now the question arises like how to solve like position. Just find the position. This should be the position of the in order. In order should be the not a post order should be not a, in order should be not a. So you have to just find the position of the index. You find the position and call the n plus 1. Now in the start index plus 2. No, I don't think so. You are calling this, and the index should be sure, this one, I don't think so. We have to just move it like right. Like 3, 3 or 20. Okay, okay, yeah, yeah, yeah. We can easily build it. Like, how can we build easily? Let me see. Let me show you. Like, it's post order IDX is equal to nothing. Just match it like, and build like a post IDX is equal to n minus 1. Now, what? Just copy from here. Just copy from here and int st int just now if the st greater than return the null, and what we have to do, like tree node tree node or the new node or the new tree node or the post order. post order dot post idx, right? Idx. Okay, post idx, post idx. Now what? Sorry, in my stream is भाई तूने आधा क्वेश्चन छोड़ दिया था, सॉल्व नहीं हुआ तो स्ट्रिंग सीधा बंद कर दिया तो भाई। बेसिकली वाईफाई। So what we have to do here is my stream is not live. So what we have to do, like uh, this is good. Now just minus it. Now what we have to do, like here, first call the new node, right? Okay, call the build function and the post, sorry, in order and the post order. Start also find the position, right? Find int mid is equal to position dot current element. We are not taking a current any, so just take a current, right? What is the current element? Post should be current element should be the post order and post ID, IDX. This should be right. Now what we have to do? Find the mid post current. Now just take like a m2n. Oh, sorry, m plus one in, and for the new node left, just call the left function like in order, in order, and post order, post order. Now, now st, and mid minus one. This and should return the new node, right? New node. What we have to do here? We just call the function build. Uh, Now let's see. This passes all the test cases. You okay? It's return now, and not a helper but a build. Okay, three node helper function. Let's see this passes all the test cases or not. This one good. Now question is that what if you are first building the left subtree and now you're again building the left right subtree. So let's see how can we build first the left again now then right. So you have to find the position of a one three three. You have a index like you can give the you can give the index should be different, right? So this is the question. Now let's move to next question. Like Maurice from first build first solve this question, right? Maurice traversal or flatten. Then again, then because this is the good question. Like serialize and deserialize. Sorry. Sorry. So now, what is this? Given the binary in order traversal, you have given return the traversal in nodes. What is the like Morris pre-order traversal? So Morris traversal. Let's say what is Morris traversal. So like Morris traversal. What is Morris traversal? What is Morris traversal? So Morris is used to traversal and unlike the recursive or stack post. That means stack based algorithm required for the stack. Morris uses the thread pointer temporarily link the subtree. Okay. Okay. Now we have to move this one. Just one approach I want to solve it using this. So can I use this like I just want to solve it using like if I am there, next index would be the left index would be like left index would be the position plus one. Find the position. So position plus one. Left index would be this, and starting should be the starting, and ending should be the position and the position minus one. Okay, and ending should be position plus one, and index would be this. So can I solve using this? So let me see the solution of others. Like can we like pointer recursive and recursive pointer recursive did construct the what is this question? It's a pre-order, not a pre-order. I want the construct to pre post order. This code. Like flatten the tree or the Morris traversal. This one, this one is easy. You have to take up like a yeah. This one I want to see the something else, right? Like how to traverse. It's both are doing right left. They all are building first the left subtree. I want to build first the left right. Okay, yeah, this one is good. So what is this do? Like X SI. What is SI? Okay, you find the position in order. Like you find the position of in order. Mm, okay, X. You find the position of the in order. Now then you find the SI. Yes. What should be the index? What should be the index you are finding? This one is so it's my like index and should be now. I solved this question using the first I build the right subtree and then the left subtree. Now, if you want to build the left subtree and then again the right subtree, you have to use the this one like this. You have to find like how many element in between the indexes. So you have to add that one, right? So this one is good. Now we have to just move out. I I solved this question like a post order, post order, uh, in order, construction, structure, right? Post order in practice. Um, so I solve it. Yes, I solved this question. Yeah, this one. See, the first I put the left click, the right side. Same, same question. Find the position, index minus 1, or index minus index. Why is it? And in this project, I just made something good, like index minus 1. Oh, sorry, index, not finding the index. You have to just returning like this is left, this is left, again right, right, left, right. That's one a good question. Like post order and in order traversal. Find the position. Find the position. Position should be as a minus I, return the position. Now left the position plus 1 in, and the index should be negative 1. Yes, answer. And index should be minus positive 1. This one is good. Now let's move the next question. Like we have first to solve the Morris pre-order traversal of a binary tree or in order of flatten. Like Morris is just a Morris. So let's suppose what the Morris said. Like you have to use the and one time spaces, like right. So one, two. So it's a same like approach, like using the what, one, two, three. It's a in order traversal, right? You can solve, but the question is that you have to solve using the Morris. So what is Morris traversal said? Morris traversals say like it is algorithm used to traverse binary tree in the Vigo of n time complex space, unlike the standard recursion or stack based memory for the call. Morris tree uses the threaded pointer temporarily link the subtree to the right subtree. Okay, zeros to one, three to one, five to this, four nothing. Oh, this one is good. So this is not so much good. This question, let's see. The flattens binary tree to the linked list. Oh, to the linked list. Given the binary tree, flatten the linked list. Linked list uses series node where the right child is now. So left, 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 right, left, right. So first solution of this code like flatten. Ah, so you can't take it out like this. So you have to just do in this like first go to left, okay, go to right, okay. Is there right child? No. So just move it up. Now you have like yeah, I have right child. I have right. So you have to not just call. First call the left, again left, go to right. Now if the right there is nothing right, you have to cut this out. You have to cut this out and take like this one. If one, two, three, four, five, six, and the seven, and here five, six, seven, eight, seven, eight, nine. Now let's call the right from here left goes. Just give me Sorry, I just so now let's move to the question. You have to flatten the binary tree to the English. Okay. So what we have to do here, like so now let's see the how can we approach this question. First try like if we go from the left, left. Okay. Go like just go from left side again left side. Okay. So left side, one, two, two. Now again three. Now we have to check like left side. So last left is left. Now it's from, from this. You have to just mark down. Just mark down now. Just mark down like this one. Just mark down. It's parent. Yeah, it's my parent like this. Like this. It's this. So it can sort that the leaks should use the tree node class where the child node pointed to the next node in the list and the left left pointer should be okay. 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 What we have to do here? Just one. Now two, three, and four. Now five. You have to just put it like from this child to all this child. Six. Last index you have to count. So list should be the pre-order traversal of a validate. Okay. What will be the solution of this? What might be the solution? Let's say like if we take flatten, so what we have to do like extra space. There is nothing need to extra space. Right. This is like what we have to do here. First go and first go and we have a root value and the like a void flat and so you have to call like a void flatten. So you have to just call from the just take a tree node and queue. Just put it like what we have to do here. Mm, if we take like a one from one, we are calling like a from two and the three. So this way is not a. Mm, I think we can use the DFS data structure. Sorry, DFS here. Like don't know how can we approach like that one. So it's like a. So it's like that means if we are calling like this like go from the left right side and make like go go to the left side. Okay, go to the left side root. Sorry, go to the right side and go to the left left side. Now just what? Just swap. That means how we can't use the swap function here. So we have to take like a tree node previous is equal to null. So now what we have to do? Like if the root is not present, if root, you have to just return the previous, not a previous, but a null ptr. Now we are calling the right function, so it's a right call right. Now again right. It's it's right. So there is no left. Now what we have to do? We have to just do like a root left should be the null value. Root left should be the null value, and the root 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 right should be the previous value. Okay, and the root and the previous value should be the root. And calling this function. Let's try this. Null ptr Latent should be not written. Okay, not done. So it's a return only. Left, we making the left because it said that the left child always be null. So we make the left and the pointer should be right. So in this question, let's suppose, yes, I think this should be run all the test cases. Yes. Okay, now, okay. So this one is, you have to just understand like making, we are traveling to the right. Now just making that if they are in left present, you have to just make a null, or that left side you have to just link with the this one. That's why we are making the first left null, and we are linking to the previous to the right, because it's make asking for the right. So another any let's see any another approach like we are counting. So it's like left, it's a 5 6, so it's a null. Now it's previous should be null, so previous should be root, previous should be root. That's good. Now let's see the next question. So we have to solve like this serialized and deserialized question, right? This one is good question, so I'm not going to solve today because the time is over, right? Yeah, wonderful. So first, let's see the today POTT problem, right? What the POTT problem is like, process the string with the special operation one. You are given the string S consisting of lowercase English letter and the special character. Okay, a special character build a new string resulting by process S according to the flowing rule from left to right, left to right, left to right. If the lower character is English letter, append the result. If it is S, remove the result. If it is, okay, remove last character from the list. Okay. If the then duplicate the current result and append to itself. Okay, and it's it. So reverse the result, return the, and what is the length? Oh, it can use the brute force approach. Like, so there two might be. Let's suppose this can be solved using the brute force approach. Uh, Copy, yeah, right? But this question, this can't be solved using brute force approach because the constraint is 10 to the power 5. And definitely the today, yes, sorry, tomorrow the POTT problem should be this. So what we can do, if we able to solve this question, then same question this will be solved. So now let's try to the harder version, right? You are given the string as consisting, the problem statement is same. No, no, problem statement. Yes, problem statement same. But in this question that you have to return the final string result after processing all character in S, right? What is this said? That you have to return the kth character of a final result. If the k is out of bound, result the empty. So what we have to do here? I think I solved it in the contest, but let's see how can we use like b star x k is equal to 1. So it's like a 1. Yeah. Okay. So what is this saying? Like if it is itna, if it is itna, sorry, if it is itna, you have to just remove the character from the one last character. So I think the here there is nothing to valid like here like a if it is remove the star and hashtag if it is hashtag you can't do anything or duplicate the result and append it. So you have A, B, C, A, B, C. If you find the itna, just remove one character from here. And if it is find itna, you have to just calculate the size. Calculate this. You have to take the this much and this much. Add this much, this much. So 2 into AB, 2 into AB. Now it's a reverse. 2 into AB. What we have to do like here? Like you have to go for the K, right? So it's A, B, C, D. Now it's let's suppose first make this question, right? This question is easy, so what we have to do? Uh, just take just take for for photo X S take a string resultant. Mhm. If the X X is greater than equal to A and then X is less than equal to Z, just add to resultant X and else if X is equal to a star and a star and and resultant and result is not empty. So just result dot pop back. Okay. So mm, else if X is equal to hashtag just result plus equal to result else just what reverse the current string, just reverse the next dot, sorry, result dot begin and result dot end, and return you have to return the return the result. So this can pass because the constraint is very low, right? Constraint is very low. That's what this passes. Now question is like how can we solve this? Like a given bind string, you are given the consisting of lower constraint string. So we have to just do like this. Like first we have to if the character is digit, just remove a character and make 1 plus 1. Okay. What is the value of k? What is the value of k? Oh, 10 to the power 15. Okay. So it's a result plus 2 into size. Just reverse the k. Mm, Now the question arises like how? Like we have to count the hashtag. Oh, sorry, hashtag star, duplicate a star, the size increases the size, increases the size, increases the size, and the reverse. So it's like a star, a band. So we are taking like a this. So it's a out of bound. So we can't take. Like what we have to do here, like a k. If we're trying to solve using that just like this, we take the string. If the if each character we insert into the resultant. Okay. If we find the star, we just go back. And if we find like this, so you just increase 2 into size. And if it is in greater than the k, you have to just remove the k from that. Okay. And it's as soon as the k becomes 0, you know the resultant area should be this. Okay, okay. Size like A, B. Okay, so remove this and size become -1. Size become -1. Now again, so what I'm trying to do here, like uh, what I'm trying to do here, we made a string like a string as mm, okay. Uh, just take a index, okay, a string and s and the bool yes reverse reverse false and take a size now currently 0. Now let's suppose x is equal to s. Now if if it is if it is if it is x is equal to a star, what we have to do? If it is x is equal to a star, if the size is, then you have to just nothing to do, right? If the sorry, if the resulting is not empty, is not empty, if the resultant is not empty, then what you have to do? Just minus is equal to 1. Size minus 1 is equal to 1. Now we have if the reverse is true, if the reverse is true, you have to result dot pop back, not result. You have to just move forward from the uh, just to take a dq, right? dq of a string. I think yes. Can I erase from the string? Can I erase character from a string from the beginning from the beginning of the string? You can. What is the substr? No, like replace character. It's a trim str. There is no function. So it's not giving the any character that we have to insert from the just I want to if it is reverse we have to just pop back from erase erase the s if erase dot can I do erase? Can I use the erase slash and substr? It's like a substr. Index should be this. No, this not. Not. How can we erase like a if it is so if it is empty, we have to just move and stop k. We have to increase the k plus one and erase. Else you have to just erase pop back, pop back, pop back. You have to just erase from the beginning of the index, right? So just take a index dot result dot sub str one. Just got it. This one is good. This one is good. Let's suppose else condition. Else if x is equal to x else is equal to x is equal to 2 star. So what we have to do? Just we have to do like what? Sj is equal to 2 into sj, and if the k is greater than sj, you have to just k minus is equal to sj, right? You have to just minus is equal to sj, and else else if else if x is equal to what percentage, you have to just reverse is equal to reverse. Oh, sorry, reverse index. Now else just add the z to is equal to else. Now what we have to do? Just like this. If the k is equal to 0, if it is become the 0, if it is become the 0, if it is become the 0, there is sure that there is sure that to find the you have find the index. If it is become, then the resultant should be return should be result dot back, right? Okay, and I think this much 10 to power 9, 10 to power 8. We are not taking the index, and else just return the like we are in the, like here from the first test case we have one and minusing one. Here you have to just minusing the one. You have to do now here. What we have to do? No, there is nothing we need here. What is the size? Size should be what? What should be size here? Size should be size plus one. Size should be one. Now it's over size one. If the size is present, you have to just minus now the character one. If it is itna, return itna. Now for this C and D, for C and D, K is equal to 3, right? Now let's suppose we got it a star. So we reverse the answer. So there is not reverse. So C, D and C, it's become D and C. Okay. Okay. Now it's a D and C. D and C. Now again the hashtag, the duplicate of the current event. Now duplicate of the current. So DC. Now again, so you have to DC and DC. So DC and DC. Now uh, you have to just size. So it's theta. So this should be the size 2 into DC. Size will be this. What should be the size? What should be the size? Size should be this, and else if it is now else 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 what we have to do? If it is now else else what we have to do? Just break it out. Like case is greater than equal to sign. If it is negative, so just break it out. Break the sign and just reverse. If the k is equal to 0, if the k is equal to 0 and the reverse is true, so you have to just uh, result dot return the result dot 0, right? And else return the result dot 0, sorry, result dot back this. Now if it is break it out, if it is break out, so now the question arises like how can we see that negative values like cd hashtag. So now let's see, like reverse value. I think this got it right. Now negative value, if the character, if the k is still greater than the sn, we can't find the hmm. Let's suppose that we have find that size into cd. So now we have to move like why this happening right now? Why result should be 0? What we have to do here? Like uh, if it is insert by the negative values, if the case if the case less than equal to 2 the size, you have to travel all the k value like a k. What should be the k? K should be the size into the itna. So the you have to just minus all the itna, right? You have to minus from the k side. That's the code. Processing the string. If we find that if we find that the k plus should be greater and k if it is negative, so it's k minus 1. It is negative, you have to just reverse it. And if it is positive, you have to just you find out that if the reverse um, like reverse, if it is true, so you have to just find out the kth index kth index kth index, like you have k is equal to 3 and the size is equal to 2 into size is equal to 4. So size is equal to 2, like size is equal to 2, size is equal to 4, size is equal to 4. So kth is equal to 4 and so You have to just you have to SG. You have to just what you have to do? Just the 4 into 3. Just AD just one. So you have to just find like a kth should be the size modulo k, right? And return the result. Result dot k. If it is reverse, you have to just return the result. Result dot size minus k, I think, and the else you have to return the you have to return the result is equal to k. Else you have to return this. The question arises like, is this the right one or the wrong one? What is k? The questions same question. So this one is good. Like let me first rewrite this. Like ro- like if x like the size we have size is equal to 0 long. We have size is equal to 0. If it is if na we can't take it like that. We can't take it out. Why this? Just take na. Like this. So we have to just not take the pop back. Just just do like the size. If the size is urgent, then we have to just size minus minus. And if it is itna, if it is itna, so if it is itna, so size should be 2 LL into size. And if it is itna, then so you can't change the size else if the condition is good, you have to just reverse the answer. This one, and else if if the x should be greater than equal to a and x should be equal to z, you have to just size plus plus. Now the question is like, can I build a long 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 each length each length like mm, long like int n is equal to s dot size, right? Now we have to find like what we have to do here. This one is good. Now this all done, just remove this one, right? Mm, if the k is greater than if the k is greater than equal to, if the k is greater than equal to size, you have to just return the empty, right? This one. Now what you have to do, like this one got you right. Now just reverse from the n I n minus 1 I reverse from the reverse. Just travel from the back side. Let's suppose the character ch is equal to si. If it is the if it is the like the ch, if it is alphabet, right? What you have to do, like what? So like if the size is equal to k, so you have to return the ch, right? Else just minus minus size minus minus. Now else if now else if now else if the ch equal to hashtag what you have to do, just size minus minus, and if the k is greater than the size, you have to just minus the size, right? Now again the question arises, like if we have as ch equal to duplicate this, what you have to do, like what if it is, so it's if it is, it just not change the character, right? It's just reverse the number. So the k value should be from the starting and minus 1 minus k, this. Else if the cs should this, so what should be the this say that you have to just append, again you have to append, right? So if the sorry, this is not a size minus size plus. Now if the size is present, you have to just, if the size is present, you have to just plus, else nothing to do, and just return the here, you have to return the semicolon. Now let's try to see, like what I'm trying. I built first the how many how much size we can build it. It's not a name character intendency. You can't build false. Just remove from me this here. Just remove here. It's it's not required. So so what we have to just post size, remove size plus 2, size plus plus. Now what this question said, unexpected member dot huh? Okay. What is this means? No, what, where I'm left any semicolon, else. Okay. Else if else if else. Now I got it. It's not giving right answer. Why? N minus 1 0 0. So it's more like a size and minus 1, resultant should be 0. What we have to do? Just character na. So just size minus minus 1 if the size is present. If it is na, then size 2l plus 1. So it's 2l plus 1. If it is it na, just increase the size. Just I increase the size. Now if it is s is equal to greater than equal to why s greater than size na. If it's greater than the equal to, let's remove that. Now we have just do to one thing what just now minus minus then return first return first minus minus then return ch. Yes, yes. First, what I have done, I have find the size of the all the characters which can be we generate, right? If the k is still not still greater than the size which we are able to produce after the processing, then we have to just return the negative one, right? Now, what we have to do? Just we have to backtrack. That means we have to just move from the back to checking the condition, right? If the k is 0, yes, k, we find the k is 0, then we have to just returning that value of ch, like ch. That character we are finding that character from that character we are 0, so we have to just return. And what this is because we are just k, we are reversing the right, and the duplicate value we are appending the value. That's why this this was, oh sorry, yeah, this one is appending. First we have appending, now we have removing, pruning. That's remove. That's the question of this. So so thank you for watching this.